Okay, we are doing, it's not really a section, is it? It's, what do we call this? Practice test? Okay, practice test. And that is page 313. So this is numbers, what is it? Like 4 to 7, right? And they just ask you to find the missing angles. Angles 1, 2, 3, and 4. So, let's take a look. We could find angle 1 if you wanted to, but there's actually an angle on here that's easiest to find. You don't have to do any math whatsoever. Yeah, angle 4, absolutely. So if I'm looking at this, you don't have to go in order, right? I mean, you don't absolutely have to, but look at angle 4. Angle 4 is a what to angle 125? Yeah, it's a vertical angle. Very good. So let's get rid of that, and let's put it into a different color. So that is 125 degrees, because vertical angles are always equal to each other, aren't they? Two lines intersect, you got pairs of vertical angles. All right, good. So we got angle, that was angle 4, right? So that's 125 degrees. There's one of our answers. That was simple. What's another one that's almost just as easy? Yeah, angle 1, I think, right? Do you see it? Look at angle 1 and look at that 125. That makes a straight line. 180 minus 125, you got it. 180 minus 125, all right, and that's 55 degrees. So angle 1 is 55 degrees. We good? Let's replace that with a 55 degrees. Good. What about angle 3? Right here.
You could add 55 degrees and 52 degrees.
Yeah. Okay, you could do that. And that's an okay way to do it. How many steps was that, though? I'd say 2 steps, right? You add them up, and then you take them away from 180, right? I'd say that was 2 steps. You can do this problem in 1 step. How can you do this problem in 1 step? How can you find angle 3 with one arithmetic problem, one basic arithmetic problem?
125
You got it. 125 minus 62. How'd you get that? How did you know to subtract those two? You got it, okay? So John's paying attention, all right? Anybody else in here? All right, okay, good. So look at this 125. This 125 right here is an exterior angle, isn't it? Right? I've got this triangle. I extended this side right here, and that right there is 125. That's an exterior angle to this triangle. Everybody see that? So what's true about that? That means the two remote interior angles add up to be 125. Well, if they tell you one of these, right, and we know that they add up to be 125, how do I find out what's left over? For instance, if I had $125 and I was going to give you $62, right, how much is left over? What do? You subtract. Exactly right. You subtract. So this is going to be what? 125 minus 62. That's a 3 and that's a 6, and there you go. 63 degrees. Now, if you wanted to, you could have, but what was my point behind doing it this way, though? Yeah, it's just 1 step. It's 1 less step. But you're absolutely right. Okay, and I said earlier that you're absolutely right. You could have gone 55 plus 62. All right, let's just do that for fun. 62 plus 55, and that's what? That's a 7, and that's an 11, 117. And so if this is 117, what do I do to find that? I got to take it away, right, from 180. That would be a 376. That's a 63. I still get the same exact answer, don't I? But what would you rather do? Would you rather do this, or would you rather do this? I would rather do this, wouldn't you? All right, I'm trying to make it easier for you. But the math is easier, but the thing is, you have to know that theorem that we talked about, that exterior angle thing. You have to be able to see that this is the exterior angle, then take this away from the exterior angle, all right? So if you see that, that's fine. What if you didn't see that? What if that didn't occur to you? Then do it this way. This is perfectly fine. There's nothing wrong with doing it this way, all right? It's fine. If you feel more comfortable doing it like this, it's perfectly okay. But I'm just trying to show you, for those who can understand this, it's just a little bit easier to take the exterior angle and take this one remote away from it, and you got the other one left over. Yep.
Can you see the other 125?
Well, yes, you could. You could have done that as well, because, yep, here's the triangle. It would be this side would be extended, and that's still an exterior angle. Absolutely. You could have looked at this one, or you could have looked at this one. Yep. Okay? All right. What else are we missing? Angle 2. Now let's think about this. Let's think about this in the same way. You could take these two, add them up, take them away from 180, couldn't you? But which one is the exterior angle here? Now you got to be a little careful though. Which one is the exterior angle to this triangle? See this skinny little triangle down here? Is it the 125? Jada, it's the 55, isn't it? Because it's not the 125 because it's not, that is not from the extension of just one of the sides, is it? The 55 is. Agreed? Because look, if I took this triangle and I just took this side right here and extended it up like that, everybody see that? So if I took this side and I extended it that way, see, that's the exterior angle, isn't it? All right, so that's the exterior angle. So what do I do to this to get angle 2? Yeah, just subtract 55 minus 32. And what's that? 23, right? And there you go. That's 23 degrees. And you got them all. Does that make sense? I didn't fill them in here. What was this? This was 23. And angle 3. Which one was angle 3? Was it this one up here? 63? Okay. Make sense? All right. Go back and watch it on YouTube if I went a little quick. If I went a little quick for you, if you're not really all there right now. I know it's afternoon, and I know you've had lunch already and all that kind of stuff, but it's getting kind of at the end of the day. I get it. Let's skip down to do the proof. Is that all right? That one we had to solve for x and y, I think that was pretty easy. I did that in the other class. If you really want to look at it, go back to the third period geometry class on YouTube. Click on it, and you'll see that problem done on there. But I want to do this one. Let's make it look like that, and let's put a line that goes from here to here. Oops, did that in the other class too. Let's make it look like that. There we go. And let's mark some stuff up. There's X, Y, Z, and W. And put some angles in here. 1, 2, 3, and 4. Alright, and here's what they tell you. They give you some stuff. Now this one, I'll tell you right now, this problem right here, this proof right here, is a little bit more difficult, just a little bit, not a whole lot, but a little bit more difficult than what I'm going to give you on the test. So if you can handle this and understand what's going on here, you should definitely be able to figure out what's on the test. While I'm thinking about it, the midterm is a perfect thing to go over, to review for the test. Remember I put some Chapter 4 problems on there? Okay, so make sure you go through those Chapter 4 problems. I told you what the answers were if you didn't get it. So go back and review those, because that'll be a great study guide for you. Not the whole entire test, because just the Chapter 4 stuff, okay? This is XW and YZ. Carol, you want to join us? Thanks. And we are trying to prove triangle XWZ is congruent to triangle ZYX. Alright. Now, I got everything written down. Let's start marking some stuff up. Let's do it in orange. Now, this is a little different. They don't usually tell you that stuff is parallel to each other, do they? So this is a little bit different, but let's see how that's going to help us. But let's mark it anyway. We can mark that. XY. Here's line segment XY, and here's line segment WZ. So we got the top and the bottom. Now, what's true about the top and the bottom? They're what to each other?
Parallel.
They're parallel. Doesn't mean they're equal, does it? It means they're parallel. So we put the little arrows there to show they're parallel. Look what else they tell you. XW, that's this left side, and YZ, that's that right side. They're parallel to each other. So I put 2 arrows there. Good, to show that they're not parallel to the 2 up top. Everybody got that? Now, how in the world does that help us? That doesn't help us with side angle side or side 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 or anything like that, does it? That doesn't mean that these 2 sides are equal and these 2 sides are equal. That has nothing to do with how long the sides are. But do you remember back, it's been a little while now, not that long ago, but remember we had 2 parallel lines cut by transversal? Remember that stuff? and then you had like 1 and 2 here. If these two lines are parallel, what's true about angle 1 and angle 2 in this little picture? It's close. Alternate. Alternate is the word we use. They're alternate interior angles. Remember that? So the alternate interior angles are equal to each other if the lines are parallel. Does that have anything to do with this picture up here? Absolutely. Look, I got two parallel lines, and I have a transversal, don't I? See, this one down, this diagonal right here, that's a transversal. So if this line is parallel to this line, and this is my transversal, what angles would be equal to each other then? 4 and 2. Well, only 4 and 2 for the top and bottom line. Look at angle 1. Angle 1's got nothing to do with this top line, does it? And angle 3 doesn't have anything to do with this bottom line. So I can't say 3 and 1. I can't say 1 and 3, but I can say 2 and 4. Because 2 connects what? It connects the top line to the diagonal, right? Or the transversal. And look what angle 4 does. Connects the bottom line to the transversal. Everybody see that? So, if the top and the bottom are parallel, that means 2 and 4 are equal to each other. But we also know that the left side and the right side are parallel to each other. So what does that tell you about some of these angles? That 1 and 3 are equal. That's right. Because look at angle 1. Angle 1 connects this left side to the transversal, and angle 3 connects the right side, see it, to the transversal. So those must be equal to each other. Now we're getting to a place where it's kind of like what was on the test before. Do we have enough information right now, this second, to prove these two triangles congruent? No. We got to do one more thing. And the whole reason I got on your case a little bit earlier, right, about that one side that was missing, is because of this problem right here. Now look, I've got an angle, and I've got another angle, right, equal to this angle times and this angle right here. What am I missing?
The side.
A side. That's right.
The side.
And yeah, this diagonal. It doesn't really bisect it, but it's a diagonal, isn't it? All right. This is my transversal. This is the side that's shared by both of these triangles. So now let's take a look at it. I've got an angle, I've got a side, and I have an angle. And that angle, or that side right there, is in between those two angles, isn't it? It's the included side. So what do I call this, Anthony? Good. I call it angle, side angle. So look, I've got an angle right here, a side here, an angle here. I've got an angle, got a side, and I've got another angle. Everybody see that? So these two triangles are congruent to each other now because of angle, side, angle. All right, there you go. Enough of that. Let's do, I didn't do number 11 in the other class. Let's see, what time do we get out of here? It's 1:40, got 5 minutes. So, yeah, if you want to see 18 and 19, I wanted to do 18 and 19, but if you want to see 18 and 19, go to the third period YouTube, and you'll see that problem done. I didn't do this one in the other class, so let me do this one right now. Because 18 and 19 you can look at on the other video. So that looks like that. This probably goes about right here to there, there to there. This looks like it goes up about like that. Does it go higher? Yeah, it looks like it goes a little higher. There we go. That's pretty close. Let's put some stuff in here. Well, that doesn't really look like 116, but that's good enough. And that's 72. And that's x. That's what we're trying to solve for right there. And they give you a couple things. They tell you that those two sides are equal, and they tell you this side is equal to this side. All right. And they just ask you to solve for x. Now, they give it to you as a multiple choice, but I wouldn't give you a multiple choice on a test or a quiz. So let's figure this out. Where do we even start with this? Where do we even start? We're trying to solve for x, right? All right, so I don't know. What do you want to do? Let's find some stuff that we can find. Let's do this. What about this? Does that help us? I mean, why would they even put that in there? Okay. Well, no, it's not. But we can go 180 minus 116. Anthony, how's that going to help us? What's that? That's 64, right? So that's right, divided by 2. Very good. You divide it by 2. Why do you divide it by 2? Because these two down here add up to be 64. But they're exactly equal to each other, aren't they? How do you know they're equal to each other? Yeah, that's called the Isosceles triangle theorem. Remember that? If two sides are equal, then the opposite angles are equal. So if these two are exactly the same and they add up to 64, we divide it by 2 and we get 32. So that's 32 and that's 32. There you go. You got it. You see it now, don't you? So knowing that angle really helps because I can find this little angle right here, can I? Yeah, what is that? That's 104, right? So it's 180 minus 104. What's that? 76? Now, does that mean this angle right here is 76? Yep, it does. Absolutely does. All right, because 180 minus these two is 76. Now, if this is 76 right here, what else do you see? Anthony, you're on a roll. Keep on going. This one right here? Okay, that's got to be 76. Good. And now I'm ready to solve for x. Now I can find x. Yeah, let's add 76 together. And that's what? 152, is that right? Good. So these are 152. To find this, you just take 180 minus 152, and that's 28, is that right? Yep. So x is 28 degrees right there. It's pretty cool, isn't it? We got to go way over here, and we work our way until we get up to this. And they gave you just enough information, too, didn't they? Does that help a little bit? All right. Now, like I said, number 18 and 19. We could do that, but it's on the other YouTube, okay? Please, use the YouTube, all right? You don't have to watch the whole entire thing. Just skip until you see, right? Just skip forward until you see 18 and 19. Just sit there for a couple minutes. It only takes a few minutes, and you can watch number 18 and 19, because you never know. I don't know if it does or not. It probably does, but I mean, you can still watch it without a YouTube account, but I don't care. I don't care about the views. I just care that you watch it, okay? I mean, I care about actual views as far as my students are concerned. I want you guys to watch it so that you can learn how to do this stuff. That's all I care about. I'm not really big into how many views did I get for this thing. The only thing that bothers me is when I get no views, which means nobody in my classes watched it. That's what I care about, okay? I don't know. I just really don't know. So what are we doing tomorrow? Taking a test, right, on what? Chapter 4. So be ready for that, okay? That is tomorrow. No, I'm going to let you hang on to this, but I'm going to collect it tomorrow. All right, so the practice test, the thing that we just finished going over, everybody listen to me? The thing we just finished going over, I'm going to collect it tomorrow. So bring it with you. Don't leave it in your locker. Don't leave it in your book. Okay, don't say you lost it or the dog ate it. You bring it in to me tomorrow. If I don't get it tomorrow by class time, I'm going to mark it late. Everybody understand that? Or you get a 0 if you don't turn it in at all. All right. Put some time into this, okay? Put some time and extra effort into it. Also, study what else? What did I tell you earlier? Study what else? The midterm. Study the problems from Chapter 4 from that midterm. That's going to help you as well. All right?